Hello, this video covers 1.4 solving quadratic equations. So take notes. All right, 1.4 solving quadratic equations. So we are going to look at a few methods: factoring, completing the square, and quadratic formula. But before we do that, let's just make sure we understand what a quadratic equation is. Okay, so it has the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not 0. Okay, so let me write that down here. Where a, b, c are real numbers, as opposed to imaginary. And a, of course, is not 0, because if it is, then we don't have a quadratic, we have a linear equation. Okay, and as an example here, maybe you have something like this: 3x squared minus 5x plus 11 equals 0. So that would be an example of a quadratic equation. Okay, so the solving methods that we are going to look at are factoring, and completing the square, and the quadratic formula. Okay, so let's go ahead and take a look at the first method, factoring. So we already looked at a whole section on how to factor. Okay, so now we're going to take a look at how we use that to solve quadratics. So we're going to be factoring, and remember, when you factor, you rewrite something as a product, as a multiplication problem. Okay, so we're going to be doing that, and then we're going to be using factoring together with what's called the zero property. Okay, and what this says is that if you have, let's say you have two factors, a and b, okay? So maybe you have this factor, we'll call it a, times this factor, we'll call it b. And let's suppose it equals 0, okay? Well, the zero property says that if you have one factor times another factor equals 0, then this is true if and only if one of those factors is equal to 0. So maybe the first factor is equal to 0, or maybe the second factor is equal to 0. Just to give you here, you don't have to copy this part down, but this is just an example. Suppose that I have 2x plus 1, x plus 3 equals 0, right? So let's suppose we have these two factors. We factor our quadratic. This is what we get. So we have these two factors. What this is saying is that if you have these two factors and they equal 0, which it says it does, this factor times this factor equals 0, what this is saying is that one of these factors must be 0. Okay, so that means that if this factor equals 0, isn't 0 times this 0? Yes. Okay. So let me go ahead and put that back. Or maybe it's this one that's 0, right? And anything times 0 is still 0. Okay, so that's what the zero property is saying, that if you have two factors, whatever they are, if you have two factors and that equal to 0, when you multiply them, one of them has to be 0. One of them equals 0. Okay, and this is true only for factors a product that's set equal to 0. Let's suppose we have it set equal to 3. Okay. This is not the case that one of them has to be 3. Okay, so one of these does not have to be 3. I could have 9 over here and 1/3 over here. Neither one of them is 3. Okay, so that's why it's going to be important that when you are solving these quadratics that you make sure that it is set equal to 0 before you start factoring. Okay, all right. Okay, so let's take a look at this example here. Let's go ahead and solve. X squared plus 5x equals 24. Okay, so here it's not set equal to 0, so I'm going to go ahead and subtract 24 on both sides. So minus 24 equals 0. So now I have it set equal to 0. Okay, very important. That way you can use the 0 property. Okay, so let's go ahead and see if this is factorable. So x times x to make x squared. I need negative 24, so one of them will be positive. The other one will be negative. Okay, and it looks like it will be 8 times 3 with the positive 8 there and the negative 3 here. And that will give me positive 5x for the middle term. Okay, so this is factored correctly. So now that it's been factored, now I am going to apply the 0 property here. So I have this factor times this one equals 0. So one of these must equal 0. So either x plus 8 equals 0 or x minus 3 equals 0. And now I solve each of these as usual. So x equals negative 8 or x equals 3. Okay. So these are the two answers that would work. Okay. Again, the most important part here when you're factoring is that you set it equal to 0 first. Okay, let's take a look at completing the square. Okay, so completing the square. So let's take a look at this example here. All right, suppose that you have to solve this. X squared plus 5x minus 24 equals 0. It's the same problem as up above, set equal to 0. But I just want to show you how you can use all of these different methods to solve the same problem. Okay, so we have this here, and the way completing the square works is what happens is you want to be able to factor it so that it's a perfect square. And then you have something else on this side. And if you can factor it so that it's a perfect square, then all you have to do is use the square root method, right? And then you can solve. Okay, so we're trying to aim for that. Okay, the only way, and if you remember, the only way this is going to be a perfect square is if it has a trinomial of the form a squared plus 2ab plus b squared, right? Okay, so we need to make sure that this fits all of this. Okay, so the way we do that is we go ahead and we find a third term that works. So what happens is I'm going to go ahead and move this negative 24 over to the other side. And the way I do that is by adding 24 to both sides. So I'm going to go ahead and add 24 on this side. Okay. Oops, I said 24, but I wrote 25. Okay. So 24, negative 24 was not working for us, so we're going to go ahead and find a nice perfect square term here that'll allow us to factor this as a square. So the way you find this number is by taking half of this number. So you're going to take half of 5. I like to leave it as a fraction. Okay, and then you're going to square it. That's how you get your perfect square. That will work. But remember now, here, let me do a different color. But remember, whatever you do on this side, if you add something on this side, then you have to also add it over here on this side. Okay, so this is, I'm going to write it as 25 over 4. Okay. All right, so when you do this process right here, taking half of this and squaring it, then this will automatically factor to x plus, if this is minus, this will be minus. This is plus, so this is plus. And this 5 halves. Okay. And then over here, I'm going to need common denominator, so which is 4. 4 times 24 is 96. Okay, and so then now, let me go ahead and add those two fractions. I get 121 over 4. Okay, and now I can go ahead and use the square root method. So I'm going to go ahead and take the square root of both sides to cancel this square. But remember, when I take the square root over here, I will have two answers, the positive and the negative. Okay? So I get x plus 5 halves equals plus minus, and the square root of 121 is 11, and the square root of 4 is 2. And then I'm going to subtract 5 halves on both sides. Okay, and so I get negative 5 halves plus minus 11 halves. Okay, so we get two answers here. So I'm going to do the addition over here, and then I'll do the subtraction over here. Okay, so x equals negative 5 halves plus 11 halves. So x equals to 6 halves. So x equals 3. And then over here, I'll do subtraction. So x equals negative 5 halves minus 11 halves. So I get x equals negative 16 over 2. So I get x equals negative 8. And we see here that 3 and negative 8 are the same answers that we got up here when we used factoring. Okay. So yeah, you might be looking at this and thinking, oh my gosh, that took a long time. Factoring was so much easier. So that's why it's nice to know how to factor, because when you're solving, oftentimes factoring is the easier, quicker method. Okay, but that's how you solve the exact same problem using completing the square. So taking a look again here at the very top, the key thing is that you are creating a third term that will allow you to factor it as the square of a binomial. Okay, and the way you get that third term is by taking half of 5 and then squaring it. Okay. Keep in mind that when you do complete the square, before you figure out this term over here, this leading coefficient here needs to be a 1. Okay, so let's take a look at an example where we don't have a 1 here. Okay, and I'll show you what you need to do. Okay, so let's solve this one, also using completing the square. But suppose that I have this. Okay, so I can't do completing the square just yet because this needs to be a 1. So this is a 3, so I will turn this into 1 by dividing everything by 3. Okay, so when I divide everything by 3, that becomes 1, which is what I need in order to complete the square. Okay, so I get x squared minus 4x plus 2 equals 0. So this is still fairly easy. This is actually easier than the previous example because this middle term right over here is an even number. Okay, so we are going to come up with a third term that works for us. So I'll have negative 2 over here. And this is going to be half of 4. Half of 4 is 2 squared. And I will write that as 4 on the other side, just to save myself a step. And this will automatically factor to x minus, because this is minus. If this were plus, this would be plus 2. And now I can go ahead and take the square root of both sides to cancel the square, but I will have plus minus. So I get x minus 2 equals plus minus the square root of 2, and then I will add 2 to both sides. So x equals 2 plus minus the square root of 2. Okay. All right, so that's completing the square. Let's take a look at the last method, quadratic formula. Maybe you remember the song of the quadratic formula, sung to the tune of Pop Goes the Weasel. If not, you can always YouTube it. All right, so here, if you have this quadratic, ax squared plus bx plus c equals 0, then the solution can be obtained using the quadratic formula. Your solutions would be x equals, and the formula is negative b. I like to use parentheses to keep track of all of my signs. I highly recommend that you also use parentheses. Plus minus the square root, b squared, minus 4 times a times c, all over 2a. Okay, so this is the quadratic formula. Hopefully you have this memorized. All right, so let's take a look at an example where you have to use this, or not where you have to use it, but where you can. So here's your quadratic. X squared plus 5x equals 24. Again, we need to make sure that this is set equal to 0. X squared plus 5x minus 24 equals 0. So a is going to be 1, b is going to be positive 5, c is going to be negative 24. Okay? All right, so let's go ahead and use the quadratic formula here. X equals negative b. B is 5 plus or minus square root b squared, so that's 5 again, minus 4 times a times c, which is negative 24, all over 2a, which is 1. 2 times 1. Okay, and working this out, that's negative 5 plus or minus square root of 25, and that is going to be plus 96. So negative times negative Okay, so that becomes positive, and that's 96 all over 2. Simplifying this, negative 5 plus or minus square root of 121 all over 2. Square root of 121 is 11. And so here I can do my two answers, negative 5 plus 11 divided by 2, and then the other answer, negative 5 minus 11. All right, so here, let's do it here. We'll do addition, negative 5 plus 11, and then down here, we'll do subtraction, negative 5 minus 11. Okay, so over here, I get 6 divided by 2, which is 3. And here I get negative 16 divided by 2, which is negative 8. And again, these are the same answers we were getting when we used the other methods. Okay, so I would say the most tricky part about quadratic formula is keeping track of your signs, which is why I say use parentheses here when you're plugging in your numbers. Okay, all right. This is just part 1 of this section, so stay tuned for part 2.